When installing a flush mount light fixture that requires a minimum of 90 degrees Celsius wire, several factors should be considered to ensure safe and compliant installation. Firstly, identifying the wire type is crucial. If the existing wire lacks a temperature code, it's possibly a type NM cable, commonly found in residential buildings. Secondly, checking for a UL listing is important. The presence of the UL mark signifies that the wire adheres to the standards set by underwriters' laboratories. Thirdly, consulting the National Electrical Code, specifically the 2020 NEC Table 310.104 and Table 310.15b16 is essential. According to these tables, type NM cable with a 600 volts rating is permitted for use in dry locations with temperatures reaching up to 90 degrees Celsius. Fourthly, it is essential to strictly follow the fixture manufacturer's instructions, specifically regarding the 90 degrees Celsius minimum wire requirement to guarantee the fixture's proper and safe functionality. Because it doesn't have a temperature rating, it is important to use the NEC code to determine whether it meets the temperature requirements of the light fixture. Even though type NM cable appears to meet the temperature requirements of the flush mount light fixture, it is highly advisable to seek guidance from a licensed electrician. This professional can verify the compatibility of the existing wiring with the new fixture, ensuring adherence to all relevant codes and regulations for safe and reliable installation. To summarize, the process involves several important steps. 1. Verify the wire type. 2. Confirm the UL listing. 3. Consult the NEC tables for temperature ratings. 4. Adhere to the fixture manufacturer's specifications. 5. When in doubt, seek the expertise of a qualified electrician. NM cable, or non-metallic sheath cable, is a common type of electrical wiring used in residential and some commercial buildings. Its construction typically consists of 2 or more insulated conductors along with a bare or insulated grounding conductor, all encased in a flexible plastic jacket. The cable is designed for interior use in dry locations. Different types of NM cable exist, such as NMB, which is the most common and is rated for 90 degrees Celsius. The rating applies to the conductor insulation within the cable, even though the overall cable jacket may have a lower temperature rating. The National Electrical Code, or NEC, plays a crucial role in electrical installations. It provides comprehensive standards and guidelines for safe electrical practices. The NEC is updated every 3 years, and it's essential to follow the latest edition adopted by the local jurisdiction. Article 334 of the NEC specifically covers non-metallic sheath cable, including NM cable. This article outlines the permitted uses, installation requirements, and restrictions for NM cable. When working with electrical wiring, safety is paramount. Always disconnect the power supply before making any electrical connections or modifications. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you're unfamiliar with electrical work, it's best to hire a licensed electrician. They have the knowledge, skills, and experience to perform electrical installations safely and correctly. Furthermore, it is also helpful to understand the specifics of conductor temperature ratings. Conductors are assigned temperature ratings that indicate the maximum temperature at which the insulation can safely operate. Common temperature ratings for conductors include 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. The temperature rating of a conductor must be considered when selecting wiring for a particular application. For example, if a light fixture requires 90 degrees Celsius wire, you must use conductors with a 90 degrees Celsius insulation rating. The ampacity of a conductor is the maximum amount of current, measured in amps, that it can safely carry without exceeding its temperature rating. The NEC provides ampacity tables that list the allowable ampacities for different types and sizes of conductors based on their temperature ratings and installation conditions. When selecting conductors for an electrical circuit, it's essential to choose the correct size and ampacity to prevent overheating and potential fire hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds the circuit's rated ampacity. The NEC specifies the requirements for overcurrent protection based on the type and size of conductors used in a circuit. It's crucial to use the correct size overcurrent protection device to ensure the safety of the electrical system. When installing electrical wiring, proper grounding is essential. Grounding provides a low impedance path for fault current to return to the source, which helps to protect people and equipment from electrical shock. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors. It's important to follow these requirements carefully to ensure a safe and effective grounding system. Electrical boxes are used to enclose and protect electrical connections. They come in various sizes and shapes to accommodate different wiring configurations. The NEC specifies the requirements for electrical boxes, including their construction, installation, and full capacity. It's important to choose a correct size electrical box for the number and size of conductors being installed. When making electrical connections, use approved connectors and methods. Wire connectors, such as wire nuts and crimp connectors, are used to join conductors together. The NEC specifies the requirements for wire connectors, including their listing, rating, and installation. It's important to use the correct type of wire connector for the application and to install it properly to ensure a secure and reliable connection. Electrical tape is used to insulate and protect electrical connections. It's important to use electrical tape that is listed for the voltage and temperature rating of the conductors being insulated. Wrap the electrical tape tightly and evenly to provide a complete and durable insulation barrier. When working with electrical wiring, it's essential to follow all applicable codes and regulations. The NEC is the primary electrical code in the United States, but local jurisdictions may also have their own electrical codes. It's important to be familiar with the codes that apply to your location and to follow them carefully. If you're unsure about any aspect of electrical wiring, it's best to consult with a licensed electrician. They can provide expert advice and assistance to ensure that your electrical work is safe and compliant. Remember that electricity can be dangerous, and it's important to take precautions to protect yourself and others from electrical shock. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Also, remember that the NEC references such as the 2020 NEC Table 310.104 and Table 310.15b16 are specific to that edition of the code. Be sure to consult the latest edition of the NEC adopted by your local jurisdiction for the most up-to-date requirements. In the original scenario, the existing wire was labeled Hatfield S-Hatflex 2/C12 AWGNM with ground 600 volts UL. While specific information on Hatfield S-Hatflex wire may be difficult to find, the key is to focus on the information provided on the cable itself, the UL listing, and the NEC guidelines. The 12 AWG indicates the wire gauge, which determines its ampacity. NM indicates that it's a non-metallic sheath cable, suitable for dry locations. With ground indicates that it includes a grounding conductor. 600 volts is the voltage rating of the cable, indicating the maximum voltage it can safely handle. By understanding these factors, you can assess the suitability of the existing wire for the new light fixture in combination with the NEC requirements and the fixture manufacturer's instructions. Remember, when dealing with electrical installations, it's always best to err on the side of caution. If you have any doubts or concerns, consult with a licensed electrician to ensure a safe and compliant installation. They can assess the specific situation and provide expert guidance based on their knowledge and experience. Electrical work can be complex and potentially dangerous, so it's important to approach it with the necessary knowledge, skills, and safety precautions. Following the steps outlined above and seeking professional assistance when needed can help ensure a safe and reliable electrical installation. Understanding the requirements for electrical installations, including wire types, temperature ratings, ampacities, overcurrent protection, grounding, and applicable codes is essential for ensuring the safety and reliability of electrical systems. By following the NEC guidelines, manufacturer's instructions, and seeking professional advice when needed, you can minimize the risk of electrical hazards and create a safe electrical environment. Now consider some potential scenarios when replacing a light fixture and how the concepts we discuss would apply. Let's say you are replacing a ceiling fan with a new, more energy-efficient model. The existing wiring is type NMP cable 14 AWG with a 90°C insulation rating. The new ceiling fan requires a dedicated circuit and a 15-amp circuit breaker. In this scenario, you would first verify that the existing NMP cable is in good condition and properly installed. Since it has a 90°C insulation rating, it meets the temperature requirements of the new ceiling fan. You would then check the ampacity of the 14 AWG wire. According to NEC Table 310.15b16, 14 AWG copper wire with a 90°C insulation rating has an ampacity of 20 amps. However, since the circuit breaker is rated for 15 amps, the 14 AWG wire is adequately protected. You would then connect the new ceiling fan to the existing wiring, following the manufacturer's instructions. Ensure that all connections are secure and properly insulated. Finally, you would test the new ceiling fan to verify that it is working properly. If you encountered any problems, such as flickering lights or humming noise, you would troubleshoot the issue and make any necessary corrections. In another scenario, let's say you are installing recessed lighting in a kitchen remodel. The existing wiring is type NM cable, but it's older and doesn't have a clear temperature rating. The recessed lighting fixtures require 90°C wire. In this case, you would need to carefully assess the condition of the existing wiring. Since it doesn't have a clear temperature rating, it's best to assume that it's rated for 60°C, which is the default rating for older NM cable. Therefore, you would need to replace the existing wiring with new NMB cable that has a 90°C insulation rating. This will ensure that the wiring meets the temperature requirements of the recessed lighting fixtures. You would also need to ensure that the new wiring is properly sized and protected by an appropriate overcurrent protection device. You would then install the recessed lighting fixtures, following the manufacturer's instructions. Ensure that all connections are secure and properly insulated. Finally, you would test the new lighting to verify that it is working properly. These examples illustrate the importance of understanding electrical wiring requirements and following the NEC guidelines. By carefully assessing the existing wiring, selecting appropriate materials, and following proper installation techniques, you can ensure the safety and reliability of your electrical system. Remember, if you're unsure about any aspect of electrical work, it's always best to consult with a licensed electrician. They can provide expert advice and assistance to ensure that your electrical work is safe and compliant. The NEC is not just a set of rules, it is a comprehensive guide for safe electrical practices. By understanding the underlying principles behind the NEC requirements, you can make informed decisions about electrical installations and avoid potential hazards. For example, the NEC specifies the minimum size conductors for different types of circuits based on their ampacity. This is to prevent the conductors from overheating and causing a fire. The NEC also specifies the type and size of overcurrent protection devices required for different circuits. This is to protect the conductors and equipment from overloads and short circuits. By following these requirements, you can ensure that your electrical system is safe and reliable. In addition to the NEC, there are also other relevant standards and regulations that may apply to electrical installations. These include standards from organizations such as UL, the National Electrical Manufacturers Association, or NEMA, and the Institute of Electrical and Electronics Engineers, or IEE. It's important to be familiar with these standards and regulations and to follow them carefully. One final important aspect of electrical work is documentation. Keep accurate records of all electrical installations, including wiring diagrams, circuit schedules, and equipment specifications. This documentation can be helpful for troubleshooting problems and for future modifications or additions to the electrical system. In conclusion, electrical work requires a combination of knowledge, skills, and safety precautions. By understanding the principles of electrical wiring, following the NEC guidelines, and seeking professional advice when needed, you can ensure the safety and reliability of your electrical system. Remember, electricity is a powerful force, and it's important to treat it with respect.